Okay, guys, the last thing we need to learn about is something called R squared. So we have learned about regression, right? We have this relationship between our points. We know it's linear, so we can draw a line to model what's going on, and we use that line for prediction. Then we generate a residual plot, and that residual plot tells us how appropriate that line is for prediction, okay? Or is there something better out there? Is there a better model out there? Lastly, we look at R squared, and R squared tells us the strength of that model, okay, that line. Is it essentially doing its job? Okay, so for example, let's go back to that idea of my husband, right? Could I, if I want to measure my husband's weight, could I measure him on a scale? Yeah, I could measure his weight on a scale. I could say, hey, honey, step on the scale for me. I need to do some statistics. Let me get your weights. But that's an appropriate measurement for weight. But is it possible that scale could be broken? Yeah, and then it's not doing its job. So we need to know, is our model doing its job? Okay, and that's called R squared. And the first thing I want you to do is just get the definition down for me, and then we'll talk more about it. So pause your video now and write this down. Okay, so you just paused your video and you're probably looking at this and be like, what the heck? What is all this? Well, let me show you one thing. When you run regression, you guys, you automatically get an R squared, okay? That's at 0.63059 we see right there, okay? So that's where in the first blank, we actually put the value of R squared here, whatever that value is, the fraction of variation in Y, okay? That needs to be in context, whatever that response variable is. That can be accounted for by the least squares regression line of Y, again, whatever that response variable is, on X, whatever that explanatory variable is. Now, this confuses people sometimes still, so there's an easy way I like to think about it. If I would draw an X and a Y axis, and I would put study time, and I would put grades on a test. Okay, whoops, that's really messy. Grades on a test. I think most people could agree, not always, right? We're always going to have some outliers, but most people could agree to some extent. The more you study, usually overall, think about the entire unit. The more you put into it, the better grade on a test you can get. And I'm not talking about just the night before. I'm talking about how well you're listening, so on and so forth. Okay, overall. Now, we could put a line, right, that models what's going on. Now, would you all agree that there could be some variation involved in the grade? So let's go back. Let's just play pretend. Let's say that R squared is equal to 0.80. Okay, let's go back to this definition now, okay? So we're just playing pretend. I just made that number up. It's an easy number to think about. R squared is equal to 0.80. Is the fraction of variation in Y. So what were we looking at? In grades. That can be accounted for by the least squares regression line of grades on study time. Now, at the bare minimum, you just have to have this in your notebook. You have to have it memorized and be able to write it down again for the test, okay? But to truly understand it, let's frame it with thinking about this whole idea of grades. R squared can actually be written as a percentage as well, only R squared. And R squared can also be called the coefficient of determination, okay? The coefficient of determination. Now, 80%, what we're saying with this whole definition that we just wrote down, we're saying that there can be variation in grades. Some people do really well, right? Are way up here. Some people are right here, and some people are way down here. There's variation in the grades. What R squared is telling us is that 80% of that change in grades is because of how much time people studied. Again, we're recognizing that there's going to be a change in the Y variable. There's going to be differences in that Y coordinate, right? We're seeing 80% of that change is accounted for because of the study time, how much people studied. But there's an extra 20% missing, right? Because out of a percentage, it's got to add up to 100%. The extra 20% means 20% of the change is because of something called lurking variables, okay? 20% of the change is because of something called lurking variables, meaning, hey, X is study time. That's influencing Y, right? That's influencing Y, our grades. But there's something else out there that's also influencing Y. And that's a lurking variable, okay? So 80% of the change in Y is because of this X of the study time. But there's another 20% out there that is affecting it, okay? And that's a lurking variable. Well, what else could affect your grades? Maybe how much you slept last night, how much you ate, if you're having relationship issues, if you're stressed because of COVID, whatever it may be, okay? No, you don't, when you're asked about the coefficient of determination or R squared, you don't need to address any of this. This is going to lead us into one more video about something called confounding variables. So you don't need to address any of this right now, okay? But I just said this so you could have a little bit better understanding of what R squared is. You do have to have this down, and on a test, guys, I'm going to be pretty word for word. You need this almost exactly as I have it. Now, could you say percentage or something else? Sure. But it pretty much has to be word for word and filling this in context. Now, while we talk about R squared, I want to actually show you a Minitab output, okay? And I'm going to post all of these notes as a PDF. So if you have a printer at home, you could just print this out and maybe cut and paste it in your notebook or whatever. You do need to know how to identify what all this stuff is on this Minitab output, okay? So some Minitab outputs are really nice and they give you the equation right away, and some aren't. It looks like we were looking at height of something, height of a tree, and then the volume of something. I don't have all the context and it does not matter, okay? But you will see Minitab outputs that look like this. That is a fact. And you may be asked to write a least squares regression line, okay? Based off this Minitab output. What you need to know is the constant that is always going to be your y-intercept. And then whatever is below, that's going to be your slope. And it's also going to give you what the explanatory variable is. Okay, so this is the explanatory variable. Always remembering that y hat is equal to a plus bx. So and they have it here for us, our y hat, our predicted volume, is equal to the y-intercept negative 87.1, they rounded there, that's okay, plus 1.4, so here's our slope, times the height. There's our least squares regression line, and they do not always give it to us, so that's why you need to know what these are right here every single time. Now, the next thing that's a really common question on the AP test is tell me what the correlation coefficient is for that data, and that's R. Well, we don't have R, but what we do have is we have R squared written as a percentage. So what we need to do, literally R squared, you guys, is taking the correlation and squaring it. So what we need to do in order to figure out R squared, or R, the correlation, is we need to take the square root of this number. But we can't take the square root of a percentage. So what we have to do first is we have to change it back to a decimal by moving that decimal place 2 to the left. That gives us 0.358. Okay? Then what I'm going to do is I'm going to take the square root of that. 0.358. I'm going to take my calculator out now and take the square root of that. And that gives me 0.59833. So R is equal to 0.59833. Now here's the catch, you guys. This is where people get things wrong. If you leave it like that, you are at a potential for losing credit. Correlation coefficient either has a positive value or a negative value. It will be one or the other. Usually we just look at the data. Is it going up or going down? So we know what it will be, or it'll pop out in our calculator. But we have our Minitab output here. So how do I know if I'm going to leave this as a positive number or a negative number? I don't have the data. I can't look at it to know, is it going up or is it going down? But hopefully you're looking at this. Give yourself a second to think, what on here will tell me if this data has a positive association or a negative association? What is it? Hopefully you're thinking in your head, the slope. The slope is positive, so my correlation has to be positive. If my slope was negative, I would have to put a negative with that correlation coefficient. This is a common question asked on the AP test. Star it, highlight it, do whatever, so you know that's going to come up again. And the last thing I want to talk about in this video is just this S. This is the standard deviation of the residuals, okay? The standard deviation of the residuals. And you will be asked to interpret that as well. So I have a statement down here for you, okay? S equals blank. So this is where you put the value. So in this case, you would say 13.40. When using X, okay, so in this case, you'd say height to predict Y, volume, we will be off by an average of 13.4 units, okay? So whatever that value is of the standard deviation plus the units. When using X to predict Y, we will be off by an average of 13.4 units, okay? Or whatever that value is. Stay tuned for, I know I said it was the last one, but stay tuned for one more video over confounding variables, and then we're done with the unit. Great job today, guys.